Hey, welcome to the second part of finding area between two curves. All right, so this should be a familiar example. We did it last time by breaking this up into two separate integrals because we wanted to take it with respect to x. Now, what we could do is we can turn things on our head a little bit. We've always taken derivatives with respect to x and integrals with respect to x. So what I want you to do is I want you to, while looking at the screen, take your head and tilt it to the right. Take your head, tilt it to the right. And when you do this, can you kind of see where that blue line equation, okay, that blue line equation is now on top of the red one. All the way, so it's on top. So when I look at this, all these values are on top of all the red values when I tilt my head to the right. I wonder if there's something that can be said about that, or what can we do about that. And as a reminder, this one here is y is equal to x minus 2, and this one here is equal to y is equal to the square root of x. And again, as a friendly reminder, this point here is 4, 2. All right, so, well, what happens, well, if I put everything in terms of y now, what if I solve for x? What if I do that? And all of a sudden, this becomes x is equal to a y plus a 2. And this one over here, square both sides, x is equal to a y squared. And now when I tilt my head to the right, what's my lower limit that I'm looking at? Now I can take a look at it this way. I can say, hey, I can make like rectangles going this way. And I can take an integration going on the y-axis. No way. And I can do that. I can say, you know what, I'm going to integrate. I'm going to start down here from 0 and go all the way up to 2, because that's where they cross. That's the area that's shot in between there. And which one's on top? Well, the blue one, which is going to be y plus 2 minus the bottom one, a y squared, dy. Why? Because these little boxes, you know, it's delta y. Whoa! Now when I go ahead and do this, I solve this up, you know, this is going to be straightforward, right? This would be y squared over 2 plus a 2y minus a y cubed over 3, evaluated from 0 to 2. I plug in 2. This is 4 plus 4 over 2, which is 2, plus a 4 minus an 8/3. And then I plug in 0 minus, 0. So it's 6, which is 18/3 minus an 8/3, which is equal to 10/3, which is the same answer that I got, but a whole lot less work. Let's compare. Here's the work that we did here. Wow, look at all that crazy work that we had to do there. Right? 2 separate integrals, a whole bunch of crazy work, still got to 10/3. Or I could just do this. Boom. 1. Ooh, that might be easier. So let's take a look at the next example. Okay, so this is going to be key. So I take a look at this next example. This next one says I get to make a choice. What it means by making a choice, do I take the integral with respect to x or with respect to y? So with respect to x, if I'm going to do this, all right, they give me two equations here, y equals x cubed, and well, x equals y squared minus 2. Well, what does that mean? Well, it means if I solve it for y, right, if I solve for y, I get y squared is equal to an x plus a 2, and to take the square root, y is equal to plus or minus the square root of x plus a 2. So when I put this in here, that's why in my calculator I've got to separate it out to a y2 and a y3 with the plus, and there's the minus, and there's the plus version. Okay? So there's my graph. If I'm going to do it with respect to x, that is, take the integral with respect to x, I have to realize something. Okay? So we're going to do it with respect to x. So let's do this. I have 3 curves, and I can see, you know what? Between here and here, one curve is always on top of the other. Okay? Which is great. All right? And then I get to this next part here. Next part, I have another part that says, well, now I have another, this curve is always on top of this other curve that we have, so that works. So I've got 2 separate integrals that I need to do. Okay? So that's one way to think about it. All right? So the next thing I could do is, well, let's think about from the y point of view. If I tilt my head again to the right, okay, so let's go ahead and get rid of this. I know you can't erase it, okay, but what if I were to go and tilt my head to the right? Now all of a sudden when I create my boxes, this is the area I'm approximating. And why? Because this function is always on top of this other function throughout the entire part. And it's just like, oh, that is pretty sweet, right? Okay? So what I need you guys to do is, I think this is where the way we want to do this. Okay? So let's get this taken care of. So it's in terms of y. Okay, so they already give this equation for us in terms of y, and that's this one here. So this is x is equal to a y squared minus a 2, and this one over here I can take the cube root, and x is equal to the cube root of y. Okay, good. All right, so that's my integration that I'm going to, that I want to do. I want to do the integral. Okay. Well, what's on top? The cube root of y minus this one right here, the y squared minus a 2 dy. The part where I'm stuck now is I don't know where these intersections are. Intersections. And again, I'm looking for the y values. So what I want you to do is on your calculator, this would be a good calculator problem that you guys can do, is we're going to take put these 3 in there in the y1, y2, y3, and you can pause my video now since you guys can take care of that. And then I'm going to do it magically like a cooking show. There it is. If I go to my y equals, okay, there's my x cubed, there's my positive square root of x plus 2, there's my negative square root of x plus 2. And I want to go and find out my intersections. So again, I go to my graph. This time, when I go to my intersections, and I go, okay, second trace, and I want to do 5 for my intersection, I have to be careful on which one I choose. Okay, so my first curve, okay, that I want to choose, okay, that's this up here, this x cubed. Yes, I do want to choose that one. Enter. My second curve. Well, again, since this is my first one, okay, that I want to do, I want to go to the bottom. So right now it's telling me it's the positive square root of x plus 2. I don't want that one, so I use my arrows. I'm going to push up. No, do I want x? No, I don't want that one again. Here we are. I want this, the negative square root of x plus 2. Okay? So I go ahead and enter. That's the second curve I want to see about intersection, and my guess is about right there. Ooh, isn't that handy? So I'm going to go back here to my notes, -1, -1. So this is, my point here is -1, -1. Okay. Now let's go take a look at the second one. Again, when I do this, I'm going to go second, trace, 5 for the intersection. For my first curve, I'm still going to choose x cubed. my second curve, I am going to choose the positive one. And I'm going to scoot over where I think the guess might be at. I hit enter. As soon as it gets done, hit enter. Alright, now it gives me a really funky one. Again, you have to pay attention to what we want. So I'm going to, quick write down the approximation. 1.214793. So 1.214, 1.793. Okay. Great. Which ones am I interested in? I'm interested in this one, and I'm interested in this one. So I know B is going to go to -1, and D is going to a 1.793 ... But again, I want to be precise. So I'm going to use this in my calculator. So I'm going to go back to my calculator. Okay. I'm going to go here to y equal, or second quit. Okay. I'm going to say I want y, so I'm going to hit alpha y, because that's going to be the y coordinate. So it's alpha 1. I'm going to store that in. Okay. I'm going to store that in the letter B. Second, our alpha B, and hit enter. Okay, so now that's in there. So now what do I want to do? I want to write out my integral. Now I can't just simply do it with what I've got already in my calculator, so I need to go ahead and take a peek down here. Okay, cube root of y minus a y squared minus a 2. So I do math 9. From a -1 to B, alpha B. And so now I'm going to do my second, see here, cube root of x. So I'm just going to do x. But you're saying, wait a second, mister, this is in y. But you can fool your calculator. Doesn't, I mean, it's the same difference divided by 3. Okay. Minus the quantity. X squared. Ooh, I have too many parentheses. X squared. Let's see here, minus x squared. X squared minus the 2. Minus 2. There we go. And dx, I hit enter. It's thinking, which if it's thinking, we do a whole lot more thinking. Alright, there's my answer, 4.214. Okay. Is equal to 4.214 or 4.215. You can round at that point or truncate. Notice I did not round right away. Okay? So let's see what's next. Our last one. Wait, didn't we just get done doing this one? Yes, in fact we've done it twice. But now I want to show the same example doing it a third way. My third way will be this. If I find the area, again remember this is y is equal to square root of x, y is equal to an x minus a 2. This point is 4, 2. If I took a look at the area underneath just this whole curve itself, and I realize, hey, you know what? There's a triangle that's right here. I could just subtract out that triangle. Okay, so now that we have this all set up, let's go ahead and set up the integration for this. So this would be the integration from 0 to 4 of my area here, which is square root of x dx minus my area of my triangle. So this first one here, okay, let's just raise it up a power, so this becomes x to the 3/2. Divide by 3/2, but the same thing as multiplying by 2/3 from 0 to 4. Minus my area of my triangle. Well, this here is 2, this here is 2. So this is 2 times 2 divided by 2 for the area of the triangle. Stick in 4. When I stick in 4, take the square root, that's 2. To the third power is 8. Times 2 is 16 over 3. Minus 2 times 2. So divide by 2, so we just got 2. Well, 2 is also the same thing as 6 over 3, which is then equal to 10/3, which is my answer. There are many ways to solve these problems. You get the same answer every time. Okay? So here we go. Here's your homework. Bada bing, bada boom. Enjoy it. Notice here, you already did number 10 on the day 1 homework. I want you to do it again, but this time solve for x and set it up with an integral, okay, of f of y dy, okay, in terms of y. Okay? I want you to do all these with the calculator. So that means set up the integral and find your intersection points with the calculator. Okay, and find the actual integral, the area. And then this one here, no calculator. Okay, that is fine. I want you to do that without a calculator and do it by hand. All right. Hope everything is going well with you guys. We'll see you on the flip side.